Hello again. This is Math 0465 coming to you from the College page. The title of this lecture is aligned with section 1.4 in your text, and it's a tale of two numbers, ratios, and proportions. As always, please be attentive while watching this video. So here are the nutritional facts for junior mids, and you want to use this information to answer the questions. Keep in mind that nutrition tables tend to be approximate values and percentages are usually rounded to whole numbers. So assume also that one serving size is a package. So here are 4 questions for you to do. What percentage of the calories in junior mints is from fat? This package accounts for 5% of a person's daily intake of fat for a 2,000 calorie diet. How is that number calculated? Number 3. What percent of a person's daily allowance of carbohydrates does she consume if she eats this whole package of junior mints? Find the answer on the label and show how it's calculated assuming a 2,000 calorie diet. And finally, on this slide, assume a person has a 500 calorie diet. What percent of his daily allowance for carbohydrates does he consume if he eats this whole package of junior mints, and round it to the nearest whole percent? So please pause the video and give this a try. Let's see how you did. And I'm using Excel to do this. So here, the percent of calories in junior mints from fat, there are 30 calories is the number of calories from fat. It's up here, 30. And there's 170 in the whole thing, so 30 over 170 is 18% if you round it that way. Now this is 5% of a person's intake. Well, again, if we're talking about grams, we have that they're supposed to get on a 2,000 calorie diet down here, 65 grams, and there's 3 grams in here. We get that from up here. So 3 over 65 is this, and they rounded it to 5%. If we want to talk about what percent of a person's daily allowance of carbohydrates, the carbohydrates down here are 300 for a 2,000 calorie diet, and this has 35 total carbohydrates, so it's 35 over 3,000. We plug it in and we would round that to 12%. Now, if we have a 2,500 calorie diet, the percent of the allowance this is raised to 375. You see that over here, the 375, but it still has 35 grams, and so 35 grams came from up here. We're talking about carbohydrates, so 35 over that ends up being close to 9%. Okay, a ratio is a comparison of two numbers and can be written in 3 different ways. For example, if the student to faculty ratio at a college is 40 to 1, the ratio can also be written as, it could be written this way, 40 to 1, or 40:1, or 40 over 1. When the quantities being compared in the ratio have different units, the ratio is called a rate. And for example, and probably the most obvious example is 30 miles per gallon is a comparison of 2 quantities, 30 miles and 1 gallon. These aren't the same units in the numerator and denominator, and it's easiest to see this is the rate. We write this as 30 miles per 1 gallon. Since the units, miles and gallons, are different, we refer to this ratio as a rate. So we're going to look at the same package label again, where I'm showing it again. We want to find the number of calories per piece of junior mint candy. If there's 16 pieces here, how many calories are there per gram? And there are 30 calories from fat. How was that number calculated and how accurate is it? Again, you should pause the video, give this a go, and see how you do. Let's see how you did. Again, using Excel. There were 16 pieces and a total of 170 calories, so you do this division. I used Excel, and you'll round it to, the nearest one would be 11. They'll probably round it to 10 on a package if they were doing that. How many calories are there per gram? Well, There are 170 calories, but then the serving size was 40 grams, so we divide those two numbers. We get 4.25, and that's between 4 and 5. You could round it down to 4 or up to 5. And the 30 calories from fat, how is that number calculated? Well, there are 30 calories from fat, and they tell you, that in the problem. The label also tells you that the calories from fat was 30, and so we're up here. But then down here they say calories per gram is 9. Okay, but there were 3 grams of fat. So 3 grams times 9 calories gives you 3 times 9 gives you 27. Now they rounded that to 30 to get this, but what they did is they multiplied these two numbers. Okay, including units in a ratio can help you decide which quantity should go in the numerator and which in the denominator. So number 8 asks you to consider, suppose you have the cruise control set at 70 miles per hour. Here are some interpretations. Which ones are correct? So please pause the video, work this problem, and then we'll see how you did. Let's see. Okay, so 70 miles per hour is the same thing as 70 miles in 1 hour. That's the same thing as doing 17.5 miles in 15 minutes. That's the same as doing 315 miles after 4.5 hours, or 70 miles every hour. D and F were incorrect. They have the wrong units. The next example, it is common for recipes and mixtures to use the term part instead of a specific unit like cup or tablespoon. A part is any unit of volume, such as a teaspoon, cup, quart, or gallon. The person who creates the mixture can choose the unit based on the amount being mixed. If we're mixing paint for a wall, a part could be a quart. If we're mixing paint for a canvas, a part could be a 1 second squirt from a paint tube. So anyway, a juice drink calls for 3 parts of orange juice and 2 parts of pineapple juice. There are several statements. You're to circle all of them that are correct. So what you should do is pause this video, work the problem, and we then can return and see how you did. Let's see how you did. The only one of these that is incorrect is number B. You see, if we say for every cup you need 1.5, you see, and this again is 1.5 of orange juice for every 2 parts here. There is that. So if you have one cup here, you need 3 times that. So that would be true. It is 1.5 because you see the ratio is the same. It's 1.5 to 1 or 3 to 2. This is 3 to 5 because you're saying what fraction is orange juice. The ratio of pineapple juice to orange juice is 2 to 3. If you have 15 ounces of orange juice, you need to have 2/3 of that of pineapple juice. That would be 10. And if you have 4 of this, you would have 6 cups of the drink because you would get each of those is going to have, actually that one's wrong too. So F is also incorrect. So B and F is incorrect because if you had 2 parts of this, you're going to have 3 parts of this. So if you have 4 of this, you're going to have 6 of this, and so that would be 6 orange juice. So that answer would be 10 instead of that. So B and F are both incorrect. There are instances when we need to determine if the ratios are equivalent. This can be done by simplifying the ratios or scaling one to see if it equals the other. And here is a nutrition label that includes suggested guidelines. So you just create a rate that compares the suggested saturated fat grams to total calories for a 2,000 calorie diet. Simplify the fraction. You do the same thing for a 2,500 calorie diet. Simplify the fractions. Compare the two and notice if in fact we have a proportional relationship, and if it grows in proportion with the size. Please pause the video and we'll see how you do. Let's see how you do. Okay, so here it was 20 per 2,000, so that rate is 0.1, and if it was 2,500 calorie, it was 25 over 2,500, again 0.1. They're the same, and we're going to say that there is, the way they're saying it is, there's less than 1%, and it is the same for those. That means they are proportional. Okay, and what does it mean? When two ratios are equal, they form a proportion. When two ratios are equal, the quantities are in proportion, or we say proportional. For example, the rates of 1 man for every woman and 3 men for every 15 women are equal because this ratio is the same as this ratio. It's man to women. Note that a specific ratio is maintained. The number of women is always 5 times the number of men. Another perspective is that when the number of men is tripled, so is the number of women. Now sometimes one ratio can be turned into another simply by scaling it. To scale a ratio, multiply or divide each quantity by the same non-zero number. And if you can scale one ratio and turn it to another, then the two ratios are equivalent. Scaling a ratio creates equivalent fractions. Okay, so here's an example. Assume your teacher assigned a 5-paragraph, 7,500 word paper early in the semester, and it took you 2.5 hours to write. If the final paper of the semester must be 3,000 words long, how long should you estimate it will take? And the question is, can you complete it in one day if you have procrastinated? So please pause the video, give this a go, and we'll see how you did. Let's see. So you see 750 words took you 2.5 hours. So to do 3,000 words, I would be multiplying by 4 up across the top, across 4 across the bottom. So it should take you 10 hours to do that problem. And 10 hours is a very long day of writing. Here's some more problems. Here's another nutrition guideline label. Nutrition guidelines suggest that we consume 25 grams of fat for a 2,000 calorie diet and 30 grams of fiber for a 2,500 calorie diet. Again, these are both grams of fiber. Is the suggested amount of fiber proportional to the number of calories? Is it almost proportional? And then you use that fact to estimate approximately how many grams of fiber should be represented for a 3,000 calorie diet. And consider the recommendations for fat, cholesterol, sodium, fiber, and protein, also shown in the previous problem, which you can see looking back, which of these proportions are almost proportional to the number of calories. So please pause the video, give this a go, and we'll see how you do. Let's see how you did. Again, using Excel, we see that 25 to 2,000 was this ratio, and 30 to 2,500 was this ratio. They're almost proportional. If you move this up to 3,000, what you see is when you go up by 500, you gain 5. So we just add this to 5, and they said 36. So you see they're almost using that same proportion. And the question asked here about fat, cholesterol, sodium, fiber, and protein. So we have to look at those. So we're looking at this kind of thing, and this is the video that you want to pause, and we'll come back and see how you do. Okay, again, I used Excel for this. We found that cholesterol and sodium are not proportional. They're the same here, here, and here. Those are limits for how much people should have, no matter how much they eat. But the others are proportional, or at least roughly proportional, and so the amounts for 3,000 would be 95 because you increased by 15 here, so you increase again by 15, you increase by 5, you increase by 5, and you increase by 15, so you increase by 15 again. So those are proportional. So the yellows are proportional, the grays are not proportional. In recent years, 2.2 million adults were in jail, and the population in the United States at the time was this many million. So per 100,000 people, how many people were incarcerated? And if your city had an incarceration rate equal to the national average, how many adults would be incarcerated? So pause the video and do the problem, and we'll come back and see how you did. Let's see how. Okay, well, 2.2 divided by 336, I could not leave them, I didn't need to write the millions. I get this percent is incarcerated. And if you take 100,000 times that, what you're going to do is you're going to move the decimal point 1, 2, 3, 4, 5 places. And so 1, 2, 3, 4, 5 places. You would have this many people per 100,000. We would round that up to this, and if I took the population of Wheaton, which was listed as 53,126, I would take 53,126 times this fraction, and there should be 348 people if we were aligned with that same thing, same proportion. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. And especially you're in this with your group. So God bless you all, and I will see you soon in another video.